Hi guys, welcome to my channel. In this video, I'm going to explain the relating different knowledge representations. So in my previous video, I explained about the accommodating the multiple paradigms. Now let's understand what is relating different knowledge representation. So let's start the video. So to represent the knowledge, this involves combining the representations such as logical formalisms, semantic networks, frames-based systems, neural network, and ontology. Logical formalisms means it's like a predicate logic, which I will be explaining you, and a semantic network also I will be explaining you, don't worry. And frame-based also I already explained briefly in my previous videos. And neural network means it is like a network from one object to many objects, from many objects to again many objects, so it is interlinked with the some networks. And ontology also I already explained. It's a study of the existence which is really exists in this real world. So I will be explaining you with this simple example so that you can understand clearly about this, how to represent the knowledge. Yeah, so the example is natural language understanding system. So first, what is the knowledge representation technique? So here we have the logical formalisms, which is nothing but the predicate logic, and semantic networks and frame-based representation. So in this they have specified three things, and we have more ontology and one more here. Yeah, similarly we have like ontologies and neural networks also. So mainly we'll be focusing on this three. Okay, yeah. So the first one is logical formalism. So what is the logical formalisms? It's like a predicate logic. So what is a predicate logic? Like take an example of weather conditions. So in a weather report, we'll be predicting the weather, how the weather will be there. So after 2 days, it may rain. It is just like a prediction. It may rain or it may be the sunny stage also. But it's like a predicting the weather condition by seeing the previous conditions. By seeing the previous conditions, we just estimate that it may rain, but it can rain or it may not be raining also. So it's like a just predicting. That is known as a predicate logic. Yes or no? So that only they are saying. So representing the knowledge, or we can say some information using the logical predicates, variables, and quantifiers. How? Let's understand with this example. So all birds can fly. This example I already explained in my previous videos also. If anyone are coming without watching those videos, please watch those videos and come to this video so that you can understand this video more clearly. Yeah, all birds can fly. Yes, this is a small this one statement which they have given. Yes, in this, what is the predicate? Can fly. Can fly is a predicate, means we are predicting that all birds can fly. Our prediction is can fly. Yes or no? So the predicate is can fly. And what is the main variable? Means like what is the main object, or we can say like variable. It's like a thing. It's a bird. Bird is a some variable. So let's consider that variable as x. Next, what is a quantifier? So mainly we have two types of quantifiers, for all and few. Means for universal we'll say for all, and one more thing is for few. These are the two quantifiers which we can use. So here we have used all. All means which is a universal. So this is the symbol for the universal. So this is the symbol for the universal for all. Okay. So this is the quantifier, and this is the variables, and this is the predicate. So to represent the knowledge, so we have to use these three conditions, which is a logical predicates, which is nothing but can fly, and the variables, which are nothing some objects which we can use in the statement, and these are the quantifiers, which are like all, for all, or for few. And these are the quantifiers. So the combination of these three things are nothing but the logical expression. So how to express by using this three? So first one is all. All means which is a quantifier, universal quantifier, means we have to specify with this symbol. As soon as, so this is a symbol for all. So for all and x. Then birds. What are the birds? Birds is nothing but the variable. So we have to specify with the x. So bird of x. Yes or no? And which maps to, which is mapping to the predicate. What is the predicate over here? Can fly. So can fly of x means what is happening over here? The variable is mapping to the predicates. So the birds are mapping to the can fly. So this is the total logical expression. Okay. So what is happening over here? the mapping technique. So the birds, like birds are nothing but the variables. So variables are mapping to the predicate. What are the thing what we are predicting? So that is mapping to this. Okay, remember this thing. So this is the logical expression. So in this way, they will be expressing the logic. So this thing they can ask in 1 or 2 marks questions also. Just they will be giving the one statements and they will be asked you to write the logical expression for the given statement. So in this way we have to represent. So we have to specify what is the predicate, what is the variables, and what are the quantifiers, and last what is the logical expression. So in this way you have to represent. Yeah, what is the logical formalisms, which is nothing but the predicate logic provides a formal and precise representation of the relationships and the constraints within the domain. Means what? It will be having some precise representation of the relationship. So this is in the form of precise thing. So it's very easy to understand, yes or no, and it is very simple. So it's a precise representation of the relationship. So we are representing the variables are mapping to the predicates, yes or no. So this is simple representation. And now let's understand what is a semantic network. So semantic networks offer a graphical representation of the concepts and their relationships. So it will be having some graphical representation. So we'll be representing this thing in the form of a graph diagrammatically. Now let's see how to represent. So basically, to represent this thing, we will be having the nodes and the edges. To represent this knowledge graphically, mainly will be focusing on the nodes and the edges. So this is a sample example. So this like birds, has wings, flies, penguins. So these are nothing but the nodes. So means this is nothing but the concept. So the main concept is nothing but the nodes. So and the edges. So the link between this thing. So from one node to another node, there is a link. There is a link between from one node to another node. So that link is nothing but the relation. So what is the relation between bird and the flies? What is the relation between bird and the penguin? So that is the relation between the nodes. That is nothing but the edge. So representing the knowledge using the nodes, which is nothing but the concept, and edges, which is nothing but the relationships, in a graphical structure. So this is like a graphical structure. Okay, let's see the example. So we have nodes and the edges in the semantic networks. So what are the nodes over here? We have bird, we have penguin and flies, and has wings are nothing but the nodes. Means like a concepts, the main concepts which are there. And what is the edge? Means what is the relation between? So now look at here. What is the relation between this bird and the flies? So bird can fly. Yes or no? Bird can fly. Yes or no? So all birds can fly. So that is the relationship. So bird and flies has a relation as can fly. So all birds can fly. So the relation between these two nodes is can fly. Yes or no? So similarly, birds have wings. So what is the relation between this? Has wings. Birds will be having a wings. Next, and penguin is a bird. So what is the relation between the penguin and a bird? Because penguin is a bird. So is. Okay, penguin is a bird. But what is happening here? Penguin is a bird, but it cannot fly. Yes or no? So in this way we have to represent things. This diagram I already explained in my previous videos. No. So same example I have taken for your reference so that you can understand more clearly. Yeah. So bird, all birds can fly. Penguin is also bird, but penguin cannot fly. Yes or no? So in this way, so we have specified with the graphical representation. So this is the graphical representation, which is nothing but the semantic network. So semantic network is specified with the nodes and the edges. Now, next one is frame-based representation. So, it represents the knowledge using the structured frames consisting of slots. So, in this frame-based representation, we'll be having some slots, which is nothing but the attributes and the variables, some slots, and what is the value for that. Okay, now let's see the example. So, what is the frame over here? Let's consider this is a frame. So, in this frame, we have bird. Bird is a frame name. Okay, and in this, we have two slots. Consider this is one slot and this is another slot. So, consider this is the first slot and this is a second slot. So what is the value for this thing? Name and the ability. So in the first slot we have a name, and in the second slot we have a ability. So what is the value for the name? Bird. And what is the value for the ability? Can fly. Okay, this is the whole frame. In this we have two slots, which is of name and the ability. What is the value of the name, which is a bird, and what is the value of this ability? Can fly. So this, the whole diagram is known as a frame based representation. We are representing the knowledge in the form of a frame. We are representing the knowledge in the form of a frame and the slots and the values. Whereas in the semantic networks, we are representing using the graphical representation by using them some nodes in the edges. So in the logical formalisms, we are using some logical expressions to represent the knowledge. So in this way, we have to represent the knowledge. So this is one type of representation of knowledge. And yeah, this is the one type of representing the knowledge. This is the one type of representing the knowledge. And this is also one of the type of the representing the logic. We are knowledge. So we have different ways to represent the knowledge. From these are the three main ways to represent the knowledge. We can represent the knowledge in many ways, but these are the main important ways how to represent the knowledge. Okay, I think you understood these three things how to represent. Now let's see. So mapping from the predicate logic to semantic network. So this is the predicate logic. So logical expression, which I already explained. Next, so what is the semantic representation? So we have the nodes and the edges. What is the relation between that? Okay, next, translating from the frame based representation to the predicate logic. So what is the frame base? In the frame base, we'll be having the slots and the values, and this is the logical expression. So this is the way. Okay, this is the way to represent the knowledge. These are the three ways to represent the knowledge. You can represent the knowledge in your wish way. Like if you know, you can represent in your own way. So they may ask like 1 or 2 marks questions also, like frame based representation of particular example they will be giving, and they will be asking to represent the particular statement using the frame based representation, or they may ask using the semantic networks, or they may ask using the predicate logic, or we can say formula. What is that? Logical formalism. So they can ask you to represent the particular statement in their own way. So you have to comfortable with every representation, every form of representation. So remember these three things. It's very easy, but if you have still any doubts in these three ways to represent the knowledge, please mention in the comment section. I will be definitely solve your doubts. Okay, and that's it for this video. Thanks for watching. Let's meet in the next video.